Hello, I'm Dr. Leonard Matheson. I'm a neurorehabilitation psychologist who has been helping people to get back to work after a brain injury since 1970. Today's talk is in response to one of the questions I get most frequently. Why do most people seem to recover from a concussion, but a sizable minority, on the order of 10% to 20%, develop permanent brain damage? This is a question that my clients and their families ask me, and one that puzzles even physicians and therapists who don't have a background in neuroscience. An important part of the answer to this question rests in a few basic brain facts. Your brain is composed of billions of neurons and hundreds of billions of support cells that require about 20% of your metabolism, principally oxygen and glucose. As a consequence, it's very sensitive to changes in your metabolism. It does a very poor job of adapting to impaired metabolism. Your neurons and support cells are bathed in a neurochemical soup that has to be just right to keep your brain healthy. When the neurochemistry in the soup is off, the cells that take care of the neurons struggle to do their work, and the neurons themselves can be overwhelmed and die. Each neuron communicates electrochemically with other neurons through synaptic gaps that are spanned by neurochemicals that have to be just right to pass the signal across the gap to the next neuron. When the neurochemistry in the gap is off, neurons can't communicate. So to maintain its health, your brain depends on stable metabolism and a stable neurochemical soup, with each neuron maintaining stable neurochemicals within itself and from one neuron to the next. When a concussion happens, your brain metabolism and key neurochemicals spin wildly out of control, putting you at risk for permanent brain damage. In 1989, neuroscientist David Hovda began to study potentially toxic changes in the brain after concussion. In 2001, he and neurologist Christopher Giza published a landmark paper in which they described what they call the neurometabolic cascade of concussion. This paper began to crystallize hundreds of research studies that pointed out that the insult to the brain didn't immediately cause brain damage, but sets off a series of events that will result in permanent brain damage if not handled properly. They called this a cascade, which is an excellent way to think about what happens after a concussion. In 2014, Dr. Hovda and Dr. Giza updated their research and the research of thousands of other scientists in a landmark paper describing the new neurometabolic cascade of concussion. In the simplest terms, a concussion kicks off toxic changes in the brain that need to be quieted down as soon as possible. What athletes call a bang on the head doesn't produce the brain injury immediately, but kicks off a cascade of wildly fluctuating neurochemicals that produce the injury to the brain. We now know that if we can calm this down, much and maybe all of the brain damage can be avoided, but we have to act quickly. Time is of the essence. Let me take a couple of minutes to introduce you to the basic ideas that Dr. Hovda and Dr. Giza present about the neurometabolic cascade. The bang on the head immediately initiates huge changes in dozens of brain systems, wildly swinging key neurochemicals out of control, a process that continues for several days. Within the first few minutes, huge amounts of potassium escape from the neuron at the same time that glutamate is indiscriminately released at the cell synapses, spreading miscellaneous nerve impulses like a nuclear reaction. Almost immediately, huge amounts of calcium flood into the neuron, threatening its very existence. Calcium stays at an extremely high level for several days. To handle the influx of calcium, the neuron's mitochondrial energy factories attempt to sequester the calcium, which bogs down the neuron's energy generation so that the neuron becomes sluggish and struggles and becomes exhausted. Within a few hours, the blood flow to the brain and the glucose available in the blood drop below normal levels and just can't keep up with the brain's overall energy demands. Neurons begin to starve. It takes several days for the brain to gradually come back to normal. To the degree that the person attempts to stay active, it gets back to normal more slowly. If the person isn't careful and has another concussion before the brain gets back to normal, neurons and their links to other neurons will begin to die by the thousands and tens of thousands and even millions, producing permanent brain damage. Athletes who recover from concussions describe it as if a bell has been rung, and that's a very accurate model as long as we consider that the ringing continues for hours and days afterwards. It's fair to say that the re-injury vulnerability continues for several days after the bang on the head, and the vulnerability to re-injury persists longer the older the athlete. The vulnerability of teenagers and young adults is shorter than it is for mature adults. So thanks for watching. You can find additional resources on this channel. Take care now.